today we are going to learn how to compute the tangent line to a curve using our one and only trusty pencil. Just kidding. We're going to use our pen instead. Nah, in all seriousness, I'll write in a Sharpie so that everyone can see what I'm writing. So, as I said, today we're going to compute the tangent line to a curve. And to do that, that also means we need to find the slope of this curved line at any given point. We can do this because the definition of a derivative of a function is f prime x, or the derivative of function f, is given by the limit of change in x as it approaches 0, 5x plus that change in x, minus the original function, all over the change in x, provided that this limit exists in the first place. Okay, and because of this definition, we know that the limit used to define the slope of the tangent line to a graph at a given point is also used to define the derivative of the function. Okay, so I just wrote down everything that I had said, and basically, because we now know this definition, and we now establish this relationship to the slope of a tangent line, we can say that by using the point slope formula, which is y minus y1 equals m times x minus x1, we can say that this m, the slope, is going to be our derivative, right? Okay. So let's say that you're told to compute the tangent line of the curve x to the fifth minus x at point 230. Okay, so the way we are going to find the slope, or this derivative of the function, is using something called the power rule, which basically says that any powers of x can be derived by nx to the n minus 1. And also, we know the rule that the derivative of the sum of two things, such as x to the fifth and negative x, is also the sum of its derivatives. So we can say that y prime, or the derivative of this function, is going to be 5x to the fourth minus 1, because the derivative of just x is going to be 1. So by using this, we know the slope of this function in terms of x. However, we want to find the slope of the tangent line at this particular point. So what we're going to do is we are going to adjust this so we can say that we're finding y prime of 2. So when we solve it out, you get something like this. And when you do it out, we find that y prime 2 is equal to 79. And this is our slope that we get to plug into our original point slope formula. And this is also the slope of this tangent line at this point when x is equal to 2. Now we can write out the point slope form because we have our slope and our point 230. So y minus 30 equals 79 times x minus 2, which when you solve it out becomes y minus 30 equals 79 x, my bad, minus 158, and then you get y equals 79 x minus 128. And now this is going to be your equation of the tangent line at the point 230 of the curve x to the fifth minus x. Okay, just so that it's neater, I rewrote down the original function. So if we were to review what we learned so far, we learned that the slope that we use to find the tangent line of a curve is the same as the derivative, because the definition of the derivative, as we said, is this right here, the limit. As change in x approaches 0, fx plus change in x minus the original function all over the change in x. And we said that this definition to find the derivative of the function is the same as the limit used to define the slope of a tangent line to a graph. Also, another step that I didn't do but usually helps me is before I go into the power rule and find the derivative, I like to just make a quick sketch of this original function. So the graph of a rough sketch of x to the fifth minus x with its zeros at -1 and 1 would look something roughly like this. And then having this idea in mind, I can try to see if the answer I get makes sense in terms of the graph of the original function. Yep, so that is how we compute the tangent line to a curve using the derivative and the definition of what a derivative is. And thank you for watching.